To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to discuss with you all some extra questions related to electronics. So in the previous chapter we discussed the questions given in your textbook. So now here I have extra question 1. As you all can see, this is the multiple choice type question. That is MCQ question where you have 4 answers and you have to select the most suitable answer. So when we say most suitable answer, you all know that there can be 2 answers which are similar, but out of that, one would be more appropriate or more suitable. So that is what we need to select here. Now if we look at the questions, the first one, a semiconductor material. Now you're familiar with semiconductors. Normally conductors are materials that allow current to pass easily through them, and insulators do not allow current to pass easily through them. So usually metals are very good conductors. Non-metals except graphite are insulators. Diamond does not allow current to flow through it, but graphite you all know because of its lattice structure, that is also a conductor. When you take the metalloids like germanium, silicon, they are semiconductors. They partially allow current to flow through them. A small amount of current can flow through these lattices. That also at somewhat higher temperatures. So you're familiar with that. So if we try to understand what a semiconductor material is, first one is arsenic. Arsenic you all know it is a group 5 element. But arsenic is a material that is used to dope a semiconductor material. You are familiar with that. To produce N-type semiconductors, we use arsenic. Then if you take silicon, silicon belongs to group 4. So usually group 4 metalloids, that is silicon, germanium, they are the semiconductors. So silicon is a semiconductor. If you take third one, boron, B is boron. Boron belongs to group 3. Now group 3 elements like boron are used to even aluminium, boron, all these are used to dope semiconductors and produce P-type semiconductors. You are familiar with that. Then we have the fourth one, silver. Silver is a metal, so it is a very good conductor of electricity. So here a semiconductor material is silicon. Then the second one, an element used to make P-type semiconductor. Now like I said, we can use both group 3 and group 5 to make semiconductors, that is to dope the semiconductors and produce P-type and N-type. Now you all can remember these, students. To a silicon lattice, if you put group 3, boron, what will happen? There will be 4 silicon atoms around it. Now there will be bonds here, covalent bonds. But boron has only 3 electrons in the outermost shell. So that will bond with 3 silicon atoms. Now this silicon atom has an electron, but this boron does not have another electron. So because of that, there will be a hole. So here we use group 3 and this will give rise to P-type semiconductors. At the same time, if we use a group 5 element like phosphorus, what happens there? Again, there are 4 silicon atoms around it because you all know when doping happens, the silicon atoms are replaced by either the group 3 element that we use like boron or group 5 element phosphorus. Now here what happens? Phosphorus has 5 electrons in the outermost shell. So 4 electrons are used up to form the bonds between silicon atoms and phosphorus. In addition to that, there will be an electron. So because of that, this becomes the N-type semiconductor. So when you use group 5, you get N-type semiconductors, and group 3 gives rise to P-type semiconductors. So there, an element used to make P-type semiconductor. You have to find an element from group 3. Now, if we look at the answers, aluminium is in group 3. Phosphorus, group 5. Then third one, nitrogen, that is also group 5. So, these two make N-type. Beryllium, of course, is in group 2. We don't usually use group 2. So, the answer is, this is group 2. Group 2. So, the answer is aluminium. An element used to make P-type semiconductor is aluminium. Boron, aluminium, all these are used to make P-type semiconductors. Is that clear, students? So, then we'll move on to the next question. 3. Select the correct answer relevant to the diagram. So, if we look at the diagram given there, now you can see there are the batteries. So, this is the positive terminal, that's the negative terminal of the battery. So, current will flow this way, and now the diode is also forward biased in that direction. So, the current can flow, then current will flow through the bulb this way. So, that means the bulb will light. If you have a circuit like this, because the current can flow through the diode. Diode is forward biased. Positive terminal of the battery is connected to the positive terminal of the diode. So, because of that, or the P terminal of the diode, P junction of the diode. So, it is forward biased. So, then, if we look at the answers given to us. Bulb does not light is incorrect. Why? The bulb can light. Bulb lights. Bulb flickers. Here there will be no flickering. Why? Because the current that is flowing from the batteries is a direct current. So, continuously there will be current flow, and also the diode will allow the current to flow. So, there will be no flickering, and bulb will light and go off after some time. That also won't happen because the dry cell will continuously supply current. So, the correct answer is going to be bulb lights. Then the fourth one, device used to obtain smoothing of full wave rectified current. What is the device used to obtain smoothing of full wave rectified current? Now, you all know, students, for rectification process, we use diode, PN junction diodes. If we use one diode, it will be half wave rectification. When we use 4 diodes as a rectification bridge, like a bridge circuit, then of course we will get the full wave rectified. But to smooth the current, that the current that is rectified, if it needs to be smoothed, then we need to use a capacitor. You all know the function of a capacitor. When we supply current to the capacitor, it will get charged. And when the current supply is stopped, it will discharge. So, because of that, capacitors can be used for smoothing processes. So, here the answers given are capacitor, that is the correct answer. Then resistor. Why do we use a resistor? Resistors are used to control the current flow through a circuit. If you use a fixed value resistor, you can reduce the current by increasing the resistance of the circuit, or else you can use variable resistors to change the resistance while the circuit is in operation. So, thereby you can change the current flow. Either way, resistors are used to control the current flow through the circuit. Then transistor. Transistor, you all know, is used for many different purposes. Transistors are used as amplifiers, current amplifier, signal amplifier, as a switch, automatic switch, like that we can use transistors. Then diode. Now, when it comes to rectification, I told you all, diode is needed. You all know that. Half wave rectification or full wave rectification. But the question is smoothing of full wave rectified current. For rectification, we need diode. But for smoothing, we need capacitor. So, that is the correct answer. We need a capacitor. Is that clear, students? So, those are the 2 questions. Device used to obtain smoothing of full wave rectified current is capacitor. Is that clear to you all? So then I'll move on to the next question. Question number 5. False statement regarding p-type semiconductors. Now false statement. You have to understand false statement regarding p-type semiconductors. So how do we get this p-type semiconductor? Now if we try to understand the p-type semiconductor again, it is the positive type. So it has to be group 3 with silicon. Group 3. I have shown the diagram before also, say like something like boron. So silicon, you will have the silicon atoms there around boron. So there will be 3 bonds. Then because boron has only 3 electrons, there will be a space here, but the electron of silicon will be there. There will be a hole there. So here this is a hole and there will be more holes than electrons. So hole is the majority charge carrier and this is the minority charge carrier. Electron will be the minority charge carrier. So that is why we call it the p-type semiconductor. Is that clear, student? So when you dope a semiconductor material like silicon with a group 3 element, aluminium, boron, any of the elements, then there will be more holes and less electrons, and holes will be the majority charge carrier and electrons will be the minority charge carrier. So that is a p-type semiconductor. Now if we look at the answers given there. False statement regarding p-type semiconductors. Holes are the majority charge carriers. That is correct. Group 3 elements are used to dope the semiconductors. That is also correct. Then number of holes increase with increase in temperature. Now normally for an intrinsic semiconductor, when it is not doped itself, when the temperature increases, number of bonds that break will increase. So because of that, there the number of holes and electrons both increase. So here the answer says number of holes increase with increase in temperature. That is also correct. The fourth one, number of holes are equal to the number of free electrons. So here the third one is also correct. Number of holes are equal to the number of free electrons. That is incorrect. Now I explained to you all, holes are the majority charge carriers and electrons are the minority charge carriers. Why? Because in a p-type semiconductor, there are more holes than electrons. So the last statement is the false statement. Number of holes are equal to the number of free electrons. That is incorrect. Then, the sixth question. They have given a symbol. You can see here that symbol, the triangle or the arrowhead with a line that indicates a diode. And when you have arrows pointing outwards from the diode, then it means it is emitting light. So this is the symbol of an LED, light emitting diode. So you are familiar with that. Normally we have the diode this way. Then if you have a diode with arrowheads pointed outwards, LED, light emitting diode. So if we look at the answers, rectifier diode. What is a rectifier diode? The normal PN junction diode is a rectifier diode. The symbol is going to be this. Here also we will need to have the two lines like that. So the first symbol will be the rectifier diode. Light emitting diode, yes, LED. Junction diode, rectifier diode, both are same. Then light dependent diode, of course, the arrowhead will be pointed towards the diode. So there the symbol is going to be like that. There the symbol will be like this, dependent diode. So outward arrowheads, light emitting, inward arrowheads pointing towards the diode will be light dependent diode. So the correct answer is going to be light emitting diode. Is that clear, students? So then I'll move on to the next question. Question number 7. The magnitude of potential barrier in a PN junction diode formed by silicon is. You are familiar with what potential barrier is. Now you can remember, students, when we have a PN junction like that, this is going to be the PN junction. There will be holes. So this is the P-type semiconductor. This side is the N-type where you will have electrons. Now at the junction, what has already happened? Now holes have been filled with electrons. So because of that, there will be a depletion layer there. This depletion layer where there are no electrons or holes. That is, the depletion layer is a neutral region, and this particular region acts as a potential barrier. And to overcome this potential barrier, we have to forward bias the diode. And depending on the semiconductor material, the potential barrier varies. You can remember, for a silicon diode, the potential barrier is 0.7. If it is germanium, the potential barrier is 0.3. So that is known as the biasing voltage. So to overcome this, we need to provide the biasing voltage. So here, if we look at the answers, the magnitude of potential barrier in a P-junction diode formed by silicon is. So there it should be PN junction diode formed by silicon is 0.3, 0.5, 0.7, 0.9. It should be 0.7 volts. Is that okay, student? So then, question number 8. Select the true statement regarding the transistor shown in the diagram. True statement regarding the transistor. So already they have told you all that it is the transistor. Now here, if you look at it, you can see the transistor symbol is standard symbol is given. They have anyway labeled the emitter, base and collector. Always this part is the base. And then how do you identify the emitter? Where you get the arrowhead is the emitter. And the direction of the arrowhead indicates the direction of the current flow. And the other third terminal will be the collector. So here you can see arrowhead is pointed outwards. That means it is an NPN transistor. If it was a PNP transistor, the arrowhead will point towards the base. Now in this, of course, the current will flow from collector base to emitter through the transistor, from the collector through the base to emitter. So that is because it is an NPN transistor. Is that okay, students? So then, you can look at the answers there. It is a PNP transistor. It is false. Why? It is an NPN transistor. Positive terminal of the battery should be connected to the base terminal of the transistor. Now, when you have a transistor like this, you can remember the forward biasing process. Now, here the base needs to be given a positive voltage, then only it will be forward bias. The same way, when you supply positive voltage to base, the collector also is given the positive voltage. Collector is supplied with the positive voltage. We'll connect it this way. So, emitter is connected to the negative terminal of the battery. Collector is connected to the positive terminal. At the same time, base is also connected to the positive terminal. Then only the transistor will be forward biased. Is that clear, students? But you can remember, always we supply a smaller voltage to the base compared to the voltage supplied to the emitter collector circuit. Is that clear? So then, If we look at the second answer, positive terminal of the battery should be connected to the base terminal of the transistor. That is correct. So, first one is incorrect. The second one is correct. Then positive terminal of the battery should be connected to the E terminal of the transistor. Is that correct? No. Here you can see emitter is connected to the negative terminal of the battery. So, that is also incorrect. Then current flows into the transistor through the emitter terminal. Is that correct? No. You can see the arrowhead points outwards. So, that means current flows outwards, away from the E terminal. So, here this statement says current flows into the transistor through the emitter terminal. That is incorrect. That is also false. So, here we have the answer, the second answer. Positive terminal of the battery should be connected to the B terminal of the transistor. That is the correct answer, because they want us to select the true statement regarding the transistor shown in the diagram. So, always when you are given a transistor, you have to look at the symbol, that is the standard symbol. You need to identify whether it is NPN or PNP. Thereafter, you all know how it is forward bias. When we say forward bias, how the terminals of the battery should be connected to the terminals of the transistor. Always the base has to be connected. If this is the NPN transistor, base has to be connected to the positive terminal. The same way, collector has to be connected to the positive terminal of the battery. But we supply a higher potential difference to the collector while a smaller voltage is supplied to the base. You have to remember that. Is that clear, students? So, then we will move on to the next question. So, question number 9. Now, there is a diagram shown to you all. You all can identify that. As you see, two graphs are given and there is a box marked as X. So, you know there should be either a component, a device or a circuit there. So, then you can identify this graph. You all know, as you see this type of graph, this has to be either potential or current, and this will be time. Same goes for this. This has to be potential or current, and this has to be time. And then you can identify here the voltage or the current is changing. The direction is changing with time. That means this has to be, or this is alternate current. Whereas here, what can you see? All the waves are on one side of the x-axis. So, there the potential or the current has become the positive part. So, there what happens? There is a full wave rectification taking place. So, this is full wave rectified. So, here we are converting the alternate current to direct current, and this has to be a full wave rectified. If it was half wave, what would happen? Now, if this has been half wave rectified, then of course you will get a graph like that. You will have a graph like this with spaces. Only the positive potential or the positive current will be there. There will be a space for the negative current. So, this is half wave. Wave rectified. So, then what should be X? Now, if it is half wave rectified, that occurs with the use of one diode. But if it is a full wave rectified, then it has to be a bridge circuit or rectifier bridge having 4 diodes connected in the appropriate manner. So, you all know how the diodes are connected there. So, here if we look at the answers given or the question and the answers, X in the diagram indicates. So, that has to be a single diode. Is it correct? No. A single diode will give a half wave rectified current. A circuit of 4 diodes. If you say a circuit of 4 diodes, that does not give a proper meaning. Now you can have a circuit where you can have 4 diodes like that. 3, 4. Now we can have something like that also. A circuit with 4 diodes. Now will this rectify the current? Now you have a circuit where the 4 diodes are connected together. Then there will be no rectification. Still the current will flow only in one direction. But only when you connect the diodes in this manner. Now you need to have one diode like that. The second diode this way. Then the third diode this way. Here also the fourth diode this way. If you have the diodes connected in this manner, then only there will be current flowing through the circuit. It is going to be like that. Then you will have the rectification process. So here, this is the proper circuit or what we call as a rectifier bridge. Rectification bridge or rectifier bridge. So then, X in the diagram indicates a single diode, no. A circuit of 4 diodes, no. A transformer. What is the function of a transformer? Now, transformer either increases the voltage if it is a step-up transformer or decreases the voltage of a current if it is a step-down transformer. So, transformer is there to change the voltage, not to rectify the current. So, the fourth answer, a bridge of 4 diodes. Here, it is a bridge of 4 diodes. That is a rectifier bridge or rectification bridge. So, that is the correct answer. Now, you have to look at the question. The waves are given, so you know alternating current becomes full wave rectified. So, for that, you need to have a bridge of 4 diodes. So, that is the bridge of 4 diodes. Is that clear, students? So then, with that, I will move on to the next question. Then question number 10. In a PNP transistor, the current flows. Now, if you are asked for a PNP transistor, you know the symbol for the PNP transistor. How do we draw that? We have the base here. So, this is the base, then we have the emitter, collector. How do we identify the emitter? Emitter needs to have the arrowhead to show the direction of the current flow. If it is a PNP transistor, current flows in this direction. Emitter base to collector in the transistor. So, that is how you will have the arrowhead. So, then, if we look at the question. In a PNP transistor, the current flows from the collector through the base to the emitter. No, the current flows from the emitter through the base to the collector. So, that is the answer we need to select. From the collector through the emitter to the base, that is also incorrect. From the emitter through the base to the collector, that is correct. That is the correct way the current flows. From the emitter through the collector to the base, that is also incorrect. So, in a transistor, now I have shown you all the diagram. You can see current flows from emitter through the base to the collector. You can remember we looked at the structure of the transistor also, how the PN regions are arranged in a transistor. You can remember that as well, students. If I show that to you all here, you can remember we have the 3 regions like that. So, we have P, N, P. So, in this, here it is the holes that are the charge carriers. So holes will flow in this direction. Because of that, current also flows in that direction. Holes and current. You can remember that. So from the emitter through the base to the collector. Is that clear? So this is the base, this is the collector, and this is the emitter there. Emitter is on this side. So you know both holes and current both flow in that manner. Emitter, base to collector. Is that clear, student? This is again to recall what we have learned and to understand that we have selected the correct answer. So here you can see in a PNP transistor, the current flows from the emitter through the base to the collector. Then the next question, that is question number 11, by doping a semiconductor with a group 5 element. So when you dope a semiconductor with a group 5 element, what happens there? Now you have the semiconductor, silicon. When you dope it with group 5, let's say phosphorus is group 5. So when you put a phosphorus, some of the silicon atoms are replaced by phosphorus. Then there should be bonds between silicon and phosphorus. Now you all know silicon has 4 valence electrons, phosphorus since it is group 5. Now here you can see group 5 element. Because of that, phosphorus will have 5 electrons. Out of the 5 electrons, 4 electrons have been used up to form 4 covalent bonds with 4 silicon atoms. There will be an additional electron. Because of that, this becomes N-type semiconductor, negative type semiconductor. There will be more electrons and less holes. Electrons will be the majority charge carriers, holes will be the minority charge carriers. Electrons, majority charge carriers. So there will be more electrons than holes. That you all know. So by doping a semiconductor with group 5 element, a p-type semiconductor can be produced? No. A n-type semiconductor can be produced? Yes. A p-type and n-type semiconductors can be produced? No. A p-n junction can be produced? No. To get a p-n junction, you have to dope with both. One side of the semiconductor should be doped with group 3 element. The other end has to be doped with group 5 element. So the correct answer here is a n-type semiconductor can be produced. So you all are familiar with that. You don't have to always draw these, students, but just for you all to recall and understand. When we do extra questions, the main aim is to recall and revise what you have already learned. That is why I am repeating most of these again and again. So with that, students, I am going to move on to the next question. Extra question 12. So here, look at the question. In intrinsic semiconductors, conductivity increases. Now, what is the meaning of intrinsic semiconductors? Again, you all know, students, if we take the silicon lattice. Now, we have the silicon lattice. What is there in silicon lattices? There are covalent bonds between silicon atoms. If this is 0 Kelvin, so here all the electrons will be in the form of bonds. There will be no free electrons. But when the temperature more than 0 Kelvin, then what happens? Now from this particular silicon lattice, now you will have bonds like that, but there can be one electron that comes out of the bond. The bond will be broken and an electron jumps out of the bond. So where the electron was earlier becomes a hole. So this becomes a hole and this becomes a free electron. So in an intrinsic semiconductor, there will be equal number of holes and free electrons. Holes are positively charged carriers and the electrons are negative charge carriers. Equal number of positive and negative charge carriers. So there the intrinsic semiconductor is electrically neutral. But at higher temperatures, because there are holes and free electrons, they can conduct electricity. But the electricity they can conduct is less because there are only a few holes and free electrons. I am sure you all can remember that. So this is an intrinsic semiconductor. So intrinsic semiconductor. Intrinsic semiconductor. Is that clear, students? So then if we go back to the question. In intrinsic semiconductors, conductivity increases as the temperature is increased because now here more than 0 kelvins, a few bonds break. When you keep on increasing the temperature, what will happen? More bonds will break. Because of that, more free electrons and more holes are generated. Therefore, the resistance decreases or the conductivity of semiconductors will increase. So here what will happen? The number of free electrons increases, correct. The number of holes increases, correct. The number of free electrons and holes increases. Which is more suitable? The third answer. The number of free electrons and holes increases. That is the most suitable answer. It depends on the type of semiconductor? No. If it is a semiconductor with the increase in temperature, there is more tendency of bonds breaking and because of that there will be more free electrons and holes. Because of that the conductivity will increase. You all have to understand that. Then the 13th question. In a transistor, the letter E indicates there are 3 terminals. You all know what the 3 terminals are: emitter, collector and base. We use the first letter of each term to indicate that particular terminal. So, emitter is E, base is B and collector is C. So, E indicates the emitter. If you look at the answers, base, emitter, collector, resistor. So, it has to be emitter. Resistor, of course, is a different component. You all know the function of resistors. We don't use a letter. It is not part of the transistor. It's not a terminal. The terminals are base, emitter and collector. So, out of that, E indicates the emitter. I'm sure you all can remember that. So, with that, students, we'll move on to the next question. Question number 14. Electronic device shown in the diagram. Now look at the diagram. What is this? It is a cylindrical structure with 2 terminals and there is a band there. A silver color band. Normally you have seen that in the lab. A cylindrical structure, usually a black color structure with a silver color or white color band. What is that? It is a diode. And here you all can remember this is the positive terminal, that is the negative terminal. So, the current flows in that direction, positive to negative. So, as you look at the diagram, you can identify it is a diode. So, here electronic device shown in the diagram. What is it? Is it a transistor? No. If it was a transistor, there will be 3 terminals and it is not a cylindrical structure. It is a diode, correct. If it was a resistor, then of course you all know if it was a fixed value resistor, that is also similar, but it is not a complete cylinder-like structure. It has a different shape. It does have 2 terminals and also you will see the colored bands. We have learned how to calculate the resistance of a fixed value resistor. So, there will be color bands in it. So from that you can differentiate the resistor. Then a capacitor. Capacitor is also a cylindrical structure, but there the capacitor does not have the terminals on the two ends. Capacitor has the terminals, both the terminals in the same part of the capacitor. So that is also different. So you are sure that this is a diode. So the answer is diode. Then the 15th one, the graph illustrates. Now if you look at the graph, what can you see here? They have plotted current with time. And you can see the curves are all in one side of the axis. That is all positive half cycles. So here you can see the waves are all in the positive direction or in the same direction. So that means the current has been rectified. And the cycles are continuous without a gap. So that means full wave rectified. Is that clear? But has it been smoothed? No. Why? Because the current drops down to 0. It fluctuates between 0 and a particular value. So it is the full wave rectified or full wave rectified current. So the graph illustrates half wave rectified current before smoothing. No. Half wave rectified current after smoothing. If it is half wave rectified current, you all have to remember all the graphs, students. If we have these two. Now here, this is, if it is current and time, current, time, this is alternate current, this is direct current. Then if you have half wave rectified after smoothing, again current with time, half wave rectified, it will be like that. If it is half wave rectified, if it is after smoothing, what happens from here to here? You get a curve like that. So this is half wave rectified, half wave rectified. This is half wave rectified after smoothing. And here, if it is current and time, if you have the full wave rectified after smoothing, what will happen? It will be something like this. Instead of the current going to the 0 and touching the x-axis, it will be a variation, a fluctuation like that. So this is full wave rectified, after smoothing. So you should know all these graphs: alternate current, direct current, then half wave rectified after smoothing, and full wave rectified after smoothing. So the graph that is given to us is only full wave rectified without smoothing. So here the answer, third one, full wave rectified current before smoothing, full wave rectified current after smoothing. So it is the third answer, full wave rectified current before smoothing. I am sure you all can remember all these graphs, students. So then we'll move on to the next question. Question number 16. So there. Select the true statement regarding the transistor shown in the diagram. So we need to select the true statement. Look at the transistor. Now here from these you can identify this is the base. Since the arrowhead is here, this is the emitter and this has to be the collector. And since the arrowhead points inwards, the current is flowing from the emitter to the base, then it has to be a PNP transistor. In a PNP transistor only, current flows from emitter base to collector through the transistor. So you can identify all those from the given symbol. So in the diagram, it is an NPN transistor. It is not correct. Terminal X is the emitter. Is it emitter? No, it is the base. Terminal Y is the emitter. That is also incorrect. Y is the collector. Terminal X is an N-type semiconductor. That is correct. This is P, this is N, that is P. So, terminal X is an N-type semiconductor. That is the correct answer or the true statement. Is that clear, students? It is a PNP transistor, so the first one is not true. It is an NPN transistor. And here you can see X is not the emitter. And Y is also not the emitter. X is base, Y is collector. And terminal X is an N-type semiconductor. That is correct since it is PNP. So, emitter P, base N, and that is P. So, that's the fourth answer. Then, question number 17. The standard symbol of a transistor is shown in the diagram. The correct answer that indicates the base, collector and emitter. So, here A, B, C are labeled. So, you all know A has to be the base. Then, C has to be the emitter. Why? Because the arrowhead points there. Arrowhead is shown there. So, that has to be the emitter and B will be the collector. That is how we identify, no? Arrowhead is indicated with the emitter. Even if you change the symbol in a different direction, different angle, but still the arrowhead is the emitter. And the direction of the arrowhead indicates the direction of the current. So, here, if we look at the answers, base, collector, emitter. Base is A, collector is B, and emitter is C. The first one is correct. So, the second answer ACB, third answer BAC, and fourth answer CBA, they are incorrect. So, the correct answer is the first one. Base A, collector B, and emitter C. Is that okay, student? So, then we will move on to the next question. Extra question 18. Part of an electronic circuit with many devices are given below. The devices A, B and C respectively are. So, if you look at the circuit, you can see here in the middle we have a transistor. Then there it is connected to batteries, dry cells. Then component A, you can identify the symbol. It is a variable resistor. And B, you can see it is a light dependent resistor. B is a light dependent resistor, LDR. And C, transistor. So, A is a variable resistor, B is a light dependent resistor, and C is the transistor. So, if we look at the answers, they want us to identify the devices A, B and C. It has to be variable resistor, light dependent resistor and transistor. That is correct. The first one is correct. Variable resistor, light dependent resistor and transistor. A variable resistor, B light dependent resistor, C diode, no. A light dependent resistor, that itself is wrong. B variable resistor, C diode. Then fourth one, A light dependent resistor, that itself wrong. B variable resistor and C transistor, that is also incorrect. So anyway, we have selected the correct answer, the first answer. With that, students, I'll move on to the next question. So here, a table is given and a symbol is also given there. Given below is a symbol of a transistor. Select the option which shows the correct type of transistor and its respective terminals. So here you can see, if you look at the transistor, Now what is this? 2, you can see it is the base. Then 3 does not have the arrowhead. So that has to be the collector. And 1 only has the arrowhead. So it is the emitter. And since the arrowhead is pointed towards the base, that means this is a PNP transistor. Is that correct? So that's how we identify. Always this part is the base, arrowhead is indicated with the emitter, and the other terminal is the collector. And since the arrowhead is pointed towards the base, it has to be a PNP transistor. So then we will select the correct answer. What is the correct answer? Option, type of transistor, NPN, NPN, PNP, PNP. So here then we have base, emitter and collector. So it has to be a PNP transistor. So from the first two options, as you see NPN, you know it's incorrect. So it has to be third or fourth, PNP. Then base is the second terminal, that is correct. Emitter is the first terminal, that is also correct, and collector is the third terminal, that is correct. If you look at the last one, base is the third one, that is wrong. 3, 1, 2. So it's wrong. The correct option is this. Third one, PNP, base is 2, emitter 1 and collector 3. Here I have marked it. Base is 2, emitter 1 and collector 3. Is that clear, students? So I'm sure you all also marked it correctly. So with that, I'll move on to the last MCQ question. Question 20. When supplying electricity to an electronic equipment, it may get damaged if the source of electricity is connected to it with the terminals reversed. You all know that there can be smoking, overheating of the electrical appliances, electronic appliances, and sometimes it can lead to fire as well. So that can damage the electronic device. So to prevent that damage, what do? We normally connect a diode that is available with the power pack itself. There will be a diode inside the power pack. So which diagram illustrates correctly how a diode should be connected to it to protect the equipment from such a damage? So they have already mentioned the diode is being connected. Now if you look at the diagram, look at the first one. Now this is the positive terminal and the negative terminal of the electronic equipment. Always you all know current flows into the equipment through the positive terminal. So usually live wire has to be connected to the positive terminal. They have connected the diode there and the direction of the diode is towards the positive terminal. So this diagram, when the current flows in through this, current can flow only in this direction and flows out. So the equipment will be protected. If by chance the terminals are connected incorrectly and current flows this way, it cannot flow out through the diode. So because of that, the first circuit will protect the device. Now look at the second one. The terminals of the diode have been changed. Here the direction of the current flow in the diode shows this way. But through the electronic device, it has to be this way. So even if the terminals are reversed, still the diode will allow the current to flow. So because of that, this diode will not protect the electronic equipment. Here what do you see? The diode is connected between these two parts. So what will happen? Current can flow to the equipment this way and this way. Diode will only allow the current to flow this way. But the current can flow through the equipment either way. So the equipment will not be protected by incorrectly connected terminals. Then look at the fourth one. They have connected the diode to the negative terminal. Normally current flows into the equipment through the positive terminal. So there also that will not provide protection. Because even if the wires are connected incorrectly, electricity will flow in the different direction. So because of that, there is no protection. Here actually the device will not work, because if the terminals are connected properly, current has to go into the equipment from the positive terminal. But here the diode will not allow the current to flow. So because of that, this will not work. So the correct circuit is the first one. This is the correct circuit, where you have the diode connected to the positive terminal of the electronic equipment. So that will allow the current to flow towards the equipment when the terminals are connected correctly. Otherwise, it will protect the equipment. Is that clear, students? So with that, I am going to end this chapter where I have completed all the MCQ type questions, and in the next chapter also I will discuss some extra questions with you.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.